Cams on everyone. Let's start off with this. Last time we did ray optics, today we'll be doing vectors, kinematics. There we have three vectors A bar, B bar, C bar. Find vector component of A bar along B bar. Find vector component of B bar perpendicular to A bar. Find area of the triangle formed by A and B. Area of vector perpendicular to A and B bar with magnitude 5. Let's get them. There I just dumped all together. All the basic questions. The second is a good one. And everyone, do make sure to keep your cams on during the session or else you'll be removed from the class. Let's get this. Try it. I'll give another 2 minutes. So how do you find vector of A bar along B bar? So this is A bar, B bar, and this is theta. So what I'm asking you to find is the component of vector along A bar, that is A cos theta in the direction of B cap. A cos theta will be A bar dot B bar by mod B bar. Dot product into B cap. How to find a unit vector? Take a vector and divide by its own magnitude. Look at the second one. Here I'm asking a vector perpendicular to A bar. Now understand one thing here. Any vector can be written as B bar, which is B parallel plus B perpendicular. Isn't it? You can write any vector so in this case, we have B bar, A bar, and theta. So if you resolve B bar into two components, this is your B parallel and this is your B perpendicular. I'm asking you for the perpendicular component. And we know B parallel component is simply B cos theta A cap. That will be A bar dot B bar by mod A bar into B cap. So B bar is B perpendicular plus B parallel. So if you want the perpendicular components, take B bar and subtract B parallel from here. So B bar minus A bar dot B bar by this will give you the perpendicular component. Everyone knows how to do the parallel thing, but if they ask you for perpendicular, you just have to subtract the parallel thing from the whole vector. You will get the perpendicular component. Is that clear, everyone? Clear with this? You know the vectors. You can substitute and solve. I will leave the working to you. What about this thing? Area of a triangle formed by A and B bar, half of A cross B bar. Yeah. Area of a parallelogram, A cross B bar. What is a vector perpendicular to A bar and B bar and magnitude 5? The vector perpendicular to A bar and B bar is A cross B, unit vector, plus or minus, because it can be up or down. And you want what magnitude? 5 times, so into 5. Is that clear? So find a unit vector perpendicular to both A and B. The vector perpendicular to A and B is A cross B, plus or minus. So get a unit vector along A cross B and multiply with 5. What about this thing? 0. A cross B vector is what? Here A is perpendicular to A cross B. B is also perpendicular to A cross B. There's no need to solve, only that. And if two vectors are perpendicular, dot product is 0. How do you check for coplanarity? The box product A, B, C, if it is 0, then coplanar. Right? If box product is 0, then coplanar. G is a good one. If A, B, C are 3 points, A, B, C, and if they form a triangle, what is the area of the triangle? You can't say A cross B. So if there are 4 points A, B, and C, you want to form a triangle. So the area will be half mod AB bar cross AC bar. Clear? It's a cross product of two sides. Hope you're clear with that. So AB bar and BC bar are this thing. So what is AB bar? AB bar is B bar minus A bar cross C bar minus A bar. And you expand this, you end up with half B cross C plus A cross B plus C cross A. That is the area of the rectangle triangle. Clear with this? I hope you know how to do the box product. In case you forgot, that's completely fine. Go and revise. AX, AY, AZ, BX, BY, BZ. It actually gives you the volume of a parallelepiped. So these three vectors will form the sides of a cuboid parallelepiped. Clear with this? Now, before jumping into this, I can even ask questions of this sort. Let's say we have a mirror. This is XY plane. This is a YZ plane mirror. And if you send a light ray like this, which is 2y, 3j plus 4k, can you find the final reflected ray? So ray optics and vectors. Let's say incident ray is 3i minus j plus 2k. Normal vector n cap is 2i plus j plus k. Find the reflected ray vector. Give vector form of Snell's law. How to do that? Remember, every time you hit a mirror, only the component perpendicular to the mirror will get inverted. Component along normal is reversed. So when you hit xy plane, the normal will be z axis. So this will be 2y plus 3j minus 4k. When you hit and bounce here, this would be x-axis is the normal. So this will be minus 2y plus 3j minus 4k. Got this? What is the vector form of Snell's law? Mu1 mod I cap cross n cap. Remember the formula mu1 sine theta is equal to mu2 sine theta r cross n cap. That will be sin I is equal to mu2 sin r. Do you guys remember this formula relation between I cap, n cap and r cap? क्या था formula relation? R cap will be I cap minus 2 times I cap dot n cap into n cap. Remember this in case you forgot. Should check out the derivation in ray optics. There, this is the vector form. Law of reflection. R cap is equal to I cap minus 2 dot I cap dot n cap into n cap. Check out page 4 ka, this was the derivation. This is a vector form. So if I give you incident ray vector and the normal, you can find the reflected ray vector. You should remember that. So if they give you some random vectors like this, you can't just see and tell the answer. This is a relation. Clear with this? That's a vector form for reflection. This is a vector form for Snell's law. Any doubts on this? Let's get this. If A bar and B bar form a parallelogram, find the condition, it becomes a rhombus. Find the condition, it becomes a square. Mod A is equal to 2, mod B is equal to 1. Angle between A and B is 60. Find angle between A plus B and 2A minus B. Right. Second is a good one actually. In overall vectors, you really don't have much tough ones. There are few ones which are a little better. First one is easy. I hope you got that. Try. I'll give you a minute or two. Let's see. So what's the condition for rhombus? In a rhombus, the diagonals are perpendicular. So first thing you should know this. So a plus b bar and a minus b bar are diagonals of a parallelogram. Right? So the condition for rhombus, a plus b bar must be perpendicular to a bar minus b bar. You could have also said the sides are equal. It would have still worked. This thing for a square, a bar must be perpendicular to b bar and mod a bar must be equal to mod b bar. Sides must be equal and the sides must be perpendicular. Clear with that? What is the next thing? You want angle between a bar and 2ab bar. So you want angle, the only thing to do is dot product. A plus b bar dot 2a minus b bar. So on the left hand side you have a dot product. On the right hand side you have a parallelogram of vectors. Mod a plus b will be a square plus b square plus 2ab cos theta root over 4a square plus b square minus 2 to 4ab cos theta. And the angle between them is cos alpha. So there alpha is the angle between a bar and b bar, a plus b bar and 2a minus b bar. So you're treating them like two vectors like c bar and d bar. So c bar dot d bar is mod c mod d cos alpha. Clear with that? You can substitute there and you can finish it off. So that will be 2a square minus 2b square plus minus a dot b. So yeah. Clear with that? You can do the working. I'll leave it to you there. Let's get this. We have a building. You have thrown two particles, one with u on the right side, one with 2u on the left side. This is another standard model. Find the time when the velocity vectors are perpendicular. Find the time when displacement vectors are perpendicular. B is the standard result. You should remember this. If you throw with u and theta, find the condition if the r bar is always increasing. Sine theta less than 8 by 9. You won't have time in the exam to derive this. But I'm not asking that. Find the time when r is perpendicular to v bar. There, we're still playing with vectors only. I am just, obviously, I can't do anything with only vectors, so I'll bring every other damn chapter. Let's get this. Projectile and vectors, the first one. Find the time when velocity vectors are perpendicular and displacement vectors are perpendicular. Let's see the 14A. Meaning the moment you say the question, like I said, within first 20-30 seconds, you should know what you're going to do. If you can't figure out in first 30-40 seconds, I think you should go ahead and do the next one. Normally in the exam. So first of all, let's get the vectors. So when this guy is going somewhere here, this will be VA bar. This will be VB bar. So VA bar, the horizontal velocity will not change, which is U into I cap. The vertical component will be minus GTJ cap. VB bar will be minus 2U I cap because it is going back. Vertical component will be minus GTJ cap. You're saying the both are perpendicular. So VA bar dot VB bar is 0. That I think minus TU square, and I will get T is equal to root 2 U by G. 2U square is equal to G square T square. Yeah. Next thing, what about the displacement vector? Displacement vector is from initial to this thing. Remember, this is your RA bar. This is your RB bar. Don't get confused. So these two green lines are perpendicular. What is the position vector? The x coordinate will be horizontal velocity into time because there's no gravity in the horizontal direction, which is ut I cap. And the vertical direction will be uyt plus half gt square, but ui is 0 here, so it's just falling down half gt square j cap. RB bar will be minus 2 ut I cap minus half gt square j cap. Now you're saying these two are perpendicular, then just do RA bar dot RB bar is equal to 0. I think here you will get 2 root 2 u by g. Clear? Projectile motion dot product. What about this guy? This though, again, you should know the whole thing actually. What is R bar? This is the general form. U cos theta T I cap. So in the previous question, if you can put theta 0, you would have got this. The vertical component will be U sine theta T minus half GT square. You should know the coordinates of the projectile and the velocity of the projectile. You know why? This is not the only question they'll ask you. They can ask you this question, find the angular momentum. Yeah, the angular momentum, MR cross V bar. So you need R bar and V bar again. So V bar will be U cos theta I cap plus U sine theta minus GT j cap. And you want them to perpendicular. So R bar dot V bar is equal to 0. Solve. I will leave it to you. Clear with this. I think you will get something like U by G sine theta. ऐसा कुछ आएगा answer. And do remember that condition. The condition, if R bar is always increasing, you should throw with an angle of less than 8 by 9 sine theta. That's the result. You can check out the notes for derivation. Quite a lengthy one, but this is something which I'm observing from last few advanced papers, right? There are certain questions they are actually asking from standard stuff. Meaning last year there was this question, you remember? There is a big ball and there's a small ball, they collide and they bounce off. There was a question like that. It was a standard model. Lengthy, right? In the exam, if you try to do that, will take almost like 4-5 minutes. But the result is very neat and small. If you know, you'll get the answers. So I think you should start mugging up. Not much, but 1 or 2 questions are coming up. Like I saw this thing happening in the last 4 or 5 years, at least 2-3 times in advance though. Mains to anyway, things will do repeat. What about this guy? Mod A bar is equal to mod B bar is equal to mod C bar. Angle between any two vectors is 60 degrees. Now, this thing, the wording is important. Between any two vectors is 60 degrees. So some people think like this. This is A bar. This is B bar. This is 60. This is 60. But A and C angle is not 60. It is 120. The three vectors are not in the same plane. There. This is the picture. The three vectors are out of the plane. So there'll be the three sides of a tetrahedron. So find mod of A bar plus B bar plus C bar. Let's see how do you do that. I can even mess up like this, like, three vectors of magnitude 1, 2, 3 with an angles of 60 degrees between them. You can play. Let's get this. So how do we do this? A bar plus B bar plus C bar ka square dot. So just do the dot product again. A bar plus B bar plus C bar. Then the formula becomes A square plus B square plus C square plus 2 A bar dot B bar plus 2 B bar dot C bar plus 2 C bar dot A bar. So on the left hand side, you'll get mod A, mod B, mod C ka square. A square ka value you know, B square, C square, 2AB cos 60, 2BC cos 60, 2CA cos 60. This is the fastest thing to do. Clear? You can expand that, A plus B plus C ka whole square. It kind of looks like that, but don't say 2AB, you say 2A bar dot B bar. Clear with this? What about this thing? R bar is T square by 2 I cap plus T cube by 3 J cap. Position vector. Find the distance traveled in 2 seconds. X is equal to T square minus 5T plus 6. Find the distance traveled in 4 seconds. Distances. Kinematics 1D ka. How do we do this? Do you guys remember the distance ka formula? This is the formula for distance. Distance is speed into time, but if your speed is changing, it is integral mod v dt. So what is v bar? dr by dt. And when you differentiate this guy, you'll get ti cap plus t square j cap. So you don't want v bar, you want mod v bar, which is root over t square plus t power 4. And then you have to integrate. Now, can you try? I'll give you a minute or two. The most common mistake what people do, they put t is equal to 2, they put t is equal to 0, and then they subtract. Then you get displacement. If you subtract your initial and the final position, you don't get distance, you get displacement. So be careful with that. If I do integral mod v dt, if you don't put a mod there, this guy becomes displacement. And this is simply r final minus r initial. That mod, and without mod, the whole answer changes. So get this. You guys all are pros at integration now. You should be able to handle it. So that's t power 4. If you integrate this, distance integral root over 1 plus t square t dt from 0 to 2. Integration by substitution. 1 plus t square is equal to, let's say, some z square. That will be t dt is equal to z dz. And this guy becomes limit. When you put 0, you get 1. When you put 2, you get root 5. And this will be z dz. That will be z cubed to 5 power 3 by 2 minus 1 by 3. That's your distance. Clear this. So be careful. Don't use the displacement ka thing. Clear this. And actually, if you look at the graph, if you actually try to plot the graph, this thing is actually going something of, it's going in a curve. This is the path. You can even find the equation of the trajectory, the x coordinate and y coordinate. This is the path. So t is equal to 2 seconds, you're somewhere here. If you just do initial and final, you're finding this dotted line. This is your displacement. I don't want that. You need distance. So you have to find this curve ka length. This is your distance. Clear this? What about the second thing? T square minus 5t plus 6. Distance traveled in 4 seconds. How do we do that? Again, same story. The moment you hear the word distance, have some fear. So x is equal to t square minus 5t plus 6. So velocity will be 2t minus 5. I still kept it simple here. So at t is equal to 5 by 2, you're going to take a turn. So at t is equal to 0, you're at x is equal to 6. So from there, you're traveling. At t is equal to 5 by 2, your velocity becomes 0, means that is when you will take a turn. You find that x coordinate. And then t is equal to 4 seconds. Again, find the x coordinate. Right? So that would be how much? 4 square? 16 minus 20 plus 6. That would be x is equal to 2. So this thing has gone actually quite a lot. There. So you need to find for the distance, you need to find this length, and you need to find this length, and then add them. That's how you get the distance. Clear? Be careful. Don't take initial and final. You'll get displacement. And I hope you remember this result. If a particle is going on if a wheel is rolling on a floor, every point on the wheel will cover a distance of 8r. The distance is 8r. Displacement is 2 pi r. And remember that's a cycloid, right? And I hope you remember this result. If a particle is going in a circle, the change in velocity is 2b sine theta by 2. Pretty standard result, comes a lot in CET kind of exams. So if a particle is going in a circle with constant speed v, find the change in velocity ka magnitude when it rotates by an angle theta by 2. Clear with this? Now, there's another variety of question. Let's say a ball collides with an incline with the u bar, which say 3i plus 4j plus 5k, something of this sort. And bounces back with v bar, which is like I minus 2j plus k cap. Find quotient of restitution. There again, vectors and collisions. This is slightly higher. Mostly, I don't think they should ask this in mains. It'll be more than mains. But yeah, based on vectors though. So your vectors, if you see, right, it is there. Matlab, as such, the chapter looks weak, but when you actually combine it with other things, you will see this at multiple places. How do we do this? This we have done in centromorph collisions. Try. I think I'll give a minute. It's a pretty good one. It's worth thinking. You're actually hitting two different things at the same time. Vectors and oblique collisions. Let's see. Listen to this. Forgot, that's completely fine, but you should know how to derive in the exam. So let's take some random incline. We don't know how is the incline. So, and this ball is going with speed u bar, collides with this and bounces off. This is your v bar. Now we know the velocity will change only along the normal. This is your normal, right? Only the velocity, component of velocities change only in the normal direction. Because force is applied along the normal, the velocity should change only in that direction. That means delta v bar change in velocity must be parallel to the normal vector. If two vectors are parallel, that means delta v cap, the unit vectors are equal. Agreed? Now, if you take this angle to be theta, and if you take this angle to be phi, we know whenever you hit a wall with speed u, you bounce back with a speed u cos theta. So if this is u cos theta, then you'll bounce back with this is v cos phi. We know u cos phi is equal to u cos theta. So basically distribution is nothing but v cos phi by u cos theta. But what is v cos phi? V cos phi is nothing but velocity along the normal. This is component of v bar along the normal. U cos theta is component of n bar. Yeah, plus or minus sign. That's okay. U bar along n cap. And you know how to take components along a vector. So then E bar will be V cos phi will be V bar dot n cap by mod n cap. Remember, AB cos theta is mod A mod B, so we can just shift it there by U bar dot n cap by mod n cap. Mod n cap is 1. And what is n cap? N cap is nothing but V bar minus U bar by mod of V bar minus U bar. So this will become V bar dot V bar minus U bar by U bar dot V bar minus U bar. So this will be V square minus U bar dot V bar by U square minus U bar dot V bar. Come on. That's your formula for restitution. Clear with this. That's a complete vector form to find quotient restitution and oblique collisions. So you can remember it however you want. You can write U bar dot V bar minus U, put a mod. You know U bar V bar, substitute, you'll get the answer. Clear how to do this? There, it's a pretty good one. I would say still an advanced problem though. But there you can see vector components how we are using. Any doubts on this? Clear? You should check out the notes in case there is more doubt on this thing. Let's get these two. Particles projected with speed u vertically, the distance traveled in the fifth and the sixth second is same. Then find h max. Particle is projected with 20 meters per second, find distance in 3 seconds. Particle is dropped from a building of height h, it covers 9h by 25 in the last second, find height of the building. All standard questions. There you can see the vectors came in ray optics, collisions. You can even bring your magnetism if you remember torque is mu cross B. They do keep popping up. Angular momentum MR cross V. Hmm. 2 more minutes, then I'll do all three. These are the kind of questions you should see and you should know what to do. It might take time to solve, that's okay. But I hope when you saw the three questions, you are like, huh, you have an idea. Okay, this is what is happening. This is what I will do. These are the steps that I should follow. That idea should click immediately. Let's see. You can still keep trying. So you're saying the distance in the fifth and the sixth second is same. Now think about this. While going up, you're slowing down. So fifth second means 4 to 5, and sixth second is 5 to 6. They can't be equal when you're going up. While coming down, the particle is speeding up. So the sixth second will travel more than the fifth second. This can happen only in one possibility. This can happen only when there is a symmetry where your t is equal to 4 is here, t is equal to 5 is here, and t is equal to 6 is here. So your fourth second, you're going from 4 to 5 h max, and the fifth second, you're coming from 5 to 6. Is that making sense? That is the only time they can be equal. Because while going up, you're slowing down. So fifth second will travel more than sixth second. While coming down, sixth will travel more than fifth. The only time they're equal is there's a symmetry. So indirectly, you gave the time of ascent as 5 seconds, which is u by g. U is 50. H max will be u square by 2g. Clear with this? So the question looks like there's no data, but you have. What about the second thing? The distance traveled in 3 seconds. Again, be careful. They're asking for distance, not displacement. So this guy goes up and comes down. So at 3 seconds, t is equal to 3, you'll be somewhere here. If you write the equation s is equal to ut plus half at square, 20 into 3 minus half g 3 square. Be careful, this gives you displacement. And t is equal to 2 is the ascent, meaning this particle is already turned back. So you're saying this is 15 meters. H max is 20 meters, so this is 5 meters. So the distance will be you went 20 up and then you came down 5. So it's 20 plus 5. Clear with this. 15 meters is the displacement. S is ut plus half at square gives you displacement. And t is equal to 2 seconds is time of ascent. So 3 seconds you asked me, this thing already turned back. What about this thing? In last 1 second, if you're covering 9h by 25, that means in t minus 1, you're covering 16h by 25. Then we can use h is equal to half gt square and 16h by 25 will be half g t minus 1 whole square. So let the total time be t. In time t, you covered h. In t minus 1, you will cover 16h by 25. From here, you can solve. You'll get t is equal to 5 and you get h is equal to 125. I remember the answer. Clear with the steps. This is what I'm saying. The moment you see the question, these things you should understand. Like in less than 30-40 seconds, you should know all the three questions. Then solving will take maybe 1 minute each or 1.5 minutes. That's okay. But if you're spending 1 minute, 1.5 minutes to figure out what to do in this level of questions, means you will have a difficulty. You will waste too much time. Let's get this thing. Three blocks V1, V2, V3. For the 1/4 of the distance, you're going V1. Second 1/4, you're going with V2. Last half distance, you're going with V3. Find average speed. We have a particle thrown off its speed. Your restitution is off. Find average speed and plot VT graph. Particle is accelerating uniformly. Initially speed is 20. Finally speed is 30. Find the speed at the midpoint. Let's see. So 1/4 of the distance. So let this being s by 4. So this time will be t1, which is s by 4 v1. This time will be s by 4 v2. This time t3 will be s by 2 v3. The better question would have been this. We did that in the notes. A particle travels with what do you call it? Speed v1 for half the distance, and with speed v2 for remaining half of the time, and v3 for the remaining time. So there is a mix-up of a distance and time ka thing. You should check out the notes. That's a much better one. So then this is easy. So what is the average speed? Total distance is s. By total time will be t1 plus t2 plus t3. That s will cancel off anyway. You'll get the answer. What about this? You're going with a constant acceleration. Find the speed at b. So here, let the speed be vb. I can use the equation v square minus u square is 2a. So vb square minus va square is 2as. vc square minus vb square will be 2as. Right? So equate them. You will get vb square is equal to va square plus vc square by 2. That's your speed. Be careful, it won't be midpoint, right? It won't be 20 plus 30 by 2. Stay with us. So I'm taking this distance as s and this is s. What about this thing? The graph is a good one. In the class notes, if you check it out, right, we did even more than this. We even plotted a distance time graph, displacement time graph, all that stuff. That was a good one. So in this, every time it collides, the speed becomes half. So you're going with u, it goes up, comes down. Then your speed becomes, did I give half? I gave half. Okay, I'll take it as EU. It goes up and comes down. Then your speed becomes E square U. It goes up and comes down and so on. H max will be U square by 2G. So this is proportional to U square. Time of flight will be 2U by G. So this is proportional to U. So if this is H max, this will be E square H. This will be E power 4H and so on. This is time. This is ET and this is E square T and so on. The average speed will be total distance by total time. The total distance will be 2 times 2h, 2 times e square h. Be careful, you're going up and down, so you have to do into 2. Then 2 e power 4h and so on until infinity. By total time will be t plus et plus e square t plus so on until infinity. Take out 2h common. Then this will become 1 plus e square plus e power 4 infinity by. I hope you remember, this is an infinite GP sequence. That will be u square by 2g. 2 will cancel. This is 2u by g. Gg will cancel. This will be u by 2. That will be 1 by 1 minus e square. 1 by 1 minus e. That will be left with u by 2 into 1 plus e. That is the formula with restitution. You can put e is equal to half and you'll get your answer. There, infinite GP, collisions, and kinematics. You want a graph? Now you can see every time the speed is becoming EU. Now be careful here. In a VT graph, slope is acceleration. So no matter how many collisions you have, acceleration remains same. The slope must remain same. So the graphs will be parallel lines. And the time will end somewhere here. The graph will not go to infinity. Even though there are infinite collisions, time is limited. So they'll get closer and closer. This is theta, this is theta, this is theta. Tan theta will be minus g. That is the slope in VT graph. So initially, if the speed was u, the speed will be eu, the speed will be e square u, and the speed will be e cube u, and so on. And this total time will be the t into 1 minus e. 1 by 1 minus e. That is the total time. The graph will not cross this point. One of the most common mistake people do that I saw, people realize there are parallel lines, but then they draw the graph like this. They'll make the graph go till infinity. Clear? The total time of collision is finite. The lines will keep on becoming smaller and smaller, but it will not exceed that. Is that clear, everyone? Clear with this? Take a 5 minute break. Come back by 9:36. We continue from here. Let's get this thing. Hope you guys remember the result for the 19A. You have a building of height h. You're throwing a particle up, down, and releasing from rest. Time of flight is T1, T2, T3. Second case, you're throwing with a speed u horizontally at an angle theta up, at an angle theta down. Time flight is T1, T2, T3. Result क्या है? Find relation between T1, T2, T3. You should know the result. You won't have time to derive this. T2 square will be T1, T3. Independent of theta. So do remember that result. You can check it out. You can prove it though, but it'll take time. That's a standard result. Get the next one. Uh, Particle is thrown from a very tall building. Find the ratio of distances in 1 second, 2 second, first second, second second, and time taken for first meter, second meter, third meter. Again, standard stuff. These are the kind of questions which will repeat a lot in CET bits. Even mains also they can come. Maybe out of 25, you'll find like, 3-4 questions of standard models. You should just know the result, mark it, and go ahead. Let's get this. And others, do keep your cams on. 19A ka proof you can check out in the notes, but you can solve it. It's just lengthy. One more question, huh? What about the speeds? When they reach the ground, if the speeds are V1, V2, V3, then who is greater? They can ask you two questions here. Find the relation between the times and find the relation between the speeds. If three particles are projected with speed u, one up, one horizontal, one down, who will reach the ground with more speed? They all will have same speed. Conservation of energy. Half mu square plus mgh is equal to half mv square. Independent of theta, no matter how you throw, they will always land at the ground with the same speed. Clear? What about the V part? Let's see. So for the first one, distances in 1 second, 2 second. So they will travel half g 1 square, half g 2 square, half g 3 square, so on. So 1 square is to 2 square is to 3 square. For the second one, you're asking in first second, meaning 1 minus 0, 2 minus 1, 3 minus 1, and so on. The 1 square, 2 square minus 1 square, 3 square minus 2 square, and so on. So this will come out to be 1, 3, 5, 7. The third one, distance for the first meter, second meter. Now see, when it is following a height h, the time taken will be root over 2h by g. So for the first meter, the time taken will be root over 2, 1 by g. Now see, he's not asking for 2 meters. We are asking for second meter, meaning you want the time for 2 meters subtracted with the time for the first meter. Then time for 3 meters and subtract the time for 2 meters. Then you end up with the sequence 1, root 2 minus 1, root 3 minus root 2, root 4 minus root 3, and so on. Clear with this? That would be the sequence for the first meter, second meter, third meter. That is, first one is root 1 minus root 0. So you can see the sequence there. It is root n minus 1. Clear? Standard stuff. Let's get these two. A rocket is starting from rest. Initially, the acceleration is a is equal to t. T is time. After 10 seconds, the engine shuts off and then it starts freely falling. Find Hmax from the ground. I can even ask you the time it takes to reach the ground, but yeah, you got the story. Second one, we have a body which is going up with you and the acceleration is minus g naught y. Means the higher you go, the more the gravity. Find Hmax and time of ascent. Variable gravity, so you can't use your regular kinematics equations. It's a little work. Try. Let's see the first one. So for the first time t, you're accelerating. So you'll reach some point here, t is equal to 10. So you'll be at a certain height and you'll also have certain speed v. At this point, you won't stop. You will go like a regular projectile and you come back. This will be v square by 2g. So I need to find h and v and my job's done. There. In the first 20-30 seconds, this is the story you have to tell yourself. Now comes the solving part. This is what I'm saying. When you start a problem, just don't start solving. 10-15 seconds, figure out what you're going to do. And if you put a picture, most of the time the idea will come. So A is equal to T. So dV by dt. V is equal to T square by 2. Put T is equal to 10, you'll get this thing. And Y coordinate will be T cube by 6. Put T is equal to 10, that will give you the height. You're done. So the total H max will be the T cube by 6 plus V square by 2g and T is equal to 10. Clear with that? Same thing here, A is equal to G naught Y. So this can be written as V dV by dy. And when you integrate this will be V dV is equal to minus G naught Y dy. Integrate this, initial speed will be U to V and 0 to Y. V square minus U square is equal to minus G naught Y square. So this is the speed as function of Y square. If you put V is equal to 0, Y will be H max, which is U by root G naught. That's your H max. You want time of flight, then you have to integrate more. That will be dy by root over U square minus G naught Y square is equal to dt. The limits will go from 0 to H max and 0 to T. This thing will come in terms of sine inverse x by a integration, that is. Right? So you can handle that. I'll leave it to you. You will get an answer in terms of something like pi by 2. Pi ka terms mein aayega answer. Clear? So this is an xt graph of a particle. Can you describe the motion? Meaning options will be like this. The speed is always increasing. The speed is always decreasing. It is always accelerating. It is decelerating. Right? Options will be like that. The particle is moving towards the x-axis. It is going away from the origin, towards the origin. Everything that you can think of. This is an xt graph. This graph is getting closer and closer to the x-axis, but it will never touch. It's a hyperbola basically there. It's a trending. Take a minute. Tell me what you can see from this graph and tell me. What do you guys think? Let's see. Look at this. If you actually xt graph, if you draw the slope, most people think you can't tell anything about acceleration, but you can. If you actually look at the slope here, the slope, you can see it is making an acute angle and it is becoming more flattish. So just to give a numbers, if I take slope like let's say 10, 5, 3, 2, 1. So you can clearly see the body is starting from x is equal to minus 10 and it is getting closer and closer to the origin, but it will never reach the origin. And as you get closer to the origin, your speed is decreasing, the slope is decreasing. And look at the slope also. Initially, the slope is decreasing at a faster rate and then it decreases at a slower rate. That means your speed is decreasing at a slower rate. That means your acceleration is also decreasing. Are you getting this? So we have a block going from -10 towards the origin. As it gets closer and closer, it becomes slower and slower. Your speed decreases, velocity and acceleration also decreases. Clear with this? Velocity is forward, acceleration is backward. A and B both are decreasing. So the speed is decreasing, but it is not decreasing as fast as before. Are you clear with this? There. XT graph. How many times displacement is zero? How many times velocity is zero? Third thing is an XY graph. It's not a graph. XY is a path. How many times velocity and average velocity become parallel? So this curve is there. This is the path of a particle. So starting from A, ending at B. How many times the velocity, instantaneous velocity and average velocity become parallel? So how many times? Look at this. So how do you get displacement? Displacement is you look at your initial position. Remember, it's an XT graph. So if you come back to the same coordinate, you have displacement zero. So you come back to the same coordinate 2, 3, 4, 5, 6. You come back to the same x coordinate 6 times, isn't it? What is velocity? In an XT graph, velocity is slope. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 times it is we have maximus and minimus critical points basically. And what about this guy? What is average velocity? So if you take any random point here, average velocity will be the initial and the final line joining. What is instantaneous velocity? Tangential, isn't it? So that means you should find a point where the the line joining from initial point should become a tangent. So from this point, if you can draw tangents, this will be the average velocity direction and also the instantaneous velocity direction. One more tangent, one more tangent, and one more tangent. Are you getting this? So from the initial point, draw tangents to the path. So at those points, your average velocity and your instantaneous velocity will be parallel. Check it out. Clear with this? That's a Vx graph. Plot Ax graph. We have two particles A and B. They're thrown with Va and Vb. Plot velocity of A with respect to B versus time, relative velocity. Assume particles stop after hitting the ground. So how do you plot this thing? So if you see this thing, it's a straight line, this thing. So minus V is equal to mx plus c. Acceleration will be v dv by dx. This would be minus m, so that will be m square x minus mc. So an Ax graph is a straight line, not passing through the origin, positive slope and a negative intercept. So when I put x is equal to 0, A must be negative. This is the graph. Clear with that? What about relative velocity? If you see relative velocity VAB will be VA minus VB. It's independent of G, meaning it does not depend on T. This is constant since A relative will be 0. The motion of one projectile with respect to another projectile is always a straight line, remember? Because the relative cancels off. But this is only till as long as they're in the air. But the moment one of them hits the ground, again it comes back to normal. So if I plot VAB versus time graph, it will be constant. Then at this point, A hits the ground. So A will stop, and then suddenly B ka relative velocity, I think it will drop and then becomes a straight line, something like this. Then it becomes a straight line. There will be a discontinuity graph. A will suddenly stop, and then B will start decelerating because speed is actually changing. Clear with this? There is another way of asking questions. Let's say a particle is projected with U. Uh, hmm. There is an air resistance where F is equal to minus kV. Right? So the particle is projected with U, gravity is also there, and it comes back with V. Find the time of flight. There's an air resistance where F is equal to minus kV bar. Find time of flight. Viscosity and kinematics. There's an interesting way to do this. If you try to do this normally, it's a mess. You can't do this normally. You can't do this on it. It'll be very complex. It'll take a lot of time. Think for a minute. There is a easier way to do. But then again, it only works for this case. Think for a minute. Is there any way you can handle this? Listen, what do you handle? This is more of an advanced question only. So when it is flying in the air, if you draw the forces mg, let's say this guy is going up with v, so your air distance also will be kv. Acceleration, so mg plus kv is equal to ma. So now what you do here, this can be written as mdv by dt. This is mg dt. This is k v bar dt is equal to, this is m dv. Now integrate this on both the sides. Now try to understand the meaning of each term. So this is the total time of flight 0 to tf, right? This will be 0 to tf, and this will be from 0 to, this will be from u to minus v. You're coming back to finally, so minus vj cap, minus vj cap. Now understand the meaning of this term here. What is v dt? V dt is displacement. And since you're throwing up, it comes back to the same point. What is the displacement? Zero. You're getting that? That integral v bar dt is displacement, and displacement is zero because you came back to the same point in time of flight. So this guy simply becomes mg time of flight is equal to m into, I think since it is decelerating, I should write a is minus dv by dt. Then this guy will be minus of minus v minus u. That will be m into u plus v. Therefore, time of flight will be u plus v by g. Clear with this? It works only for this thing, because if I make this kv square, you're gone. It won't work. You'll get integral v square dt. You can't solve that. Is that making sense? So it's a very interesting way of handling this kind of a question. I mean, generally, if you have seen this before, you'll get an idea. First time, it's difficult. Normally, we see this and try to, integrate. And the biggest idea is this: you know the final velocity. If you don't know the final velocity, you can't solve the problem. Clear with this? That's one. Another one. Let's say we have a building, tall building. We have a particle projected horizontally with speed u, and we have an air resistance F is equal to minus kV bar. Find x and y coordinate. For convenience here, you can take this point as origin, take this downward as y-axis, and that as x-axis. Acceleration is same direction as force. Nee, na, what is A? A is dv by dt, right? And your speed is changing, na? So dv is negative that way. This is a good one. So normal, this is a kinematics with the air resistance problems. I think we did in viscosity this thing. I don't remember, but let's see. Try. I'll give 2-3 minutes. At least get me the main equations. Integrations you guys can handle. That much is fine now. I'm more interested in getting the equations right. So how do we get the steps here? Let's check whether we did this in kinematics though. Yeah, we didn't do this thing. So let's say at some point here, this guy is going with velocity. Let the velocity be Vx I cap and Vy j cap. So if you look at the forces here, this will be mg, and the viscous force will be kVy, and this will be kvx. It looks scary, but it is actually pretty decent integration. So in the vertical direction, mg minus kvy is equal to m into acceleration in the y direction. That will be dvy is equal to g minus k by m vy by dt. You can integrate this. dvy minus g by km vy is equal to dt. Integrate this. 0 to t, initially vertical velocity is 0, and this is vy. This guy will be minus m by k ln g minus k by m, and put a 0 there. So 1 minus k vy by mg is equal to t. So we get vy is equal to mg by k into 1 e power minus kt by m. That's your vy. Similarly, if you do for the vx, ax will be equal to minus kvx, and if you integrate this, that will be dvx by dt. You will get vx will be initial velocity u into e power minus kt by m. You can integrate this again, you can get an x coordinate. That would be u mu by k into 1 into e power minus kt by m. Y coordinate also you can integrate. But you get some pretty interesting result here. Huh? If you actually try to draw the path, and if you look at the coordinates we got, look at that x coordinate we got. They can ask you this question, find the range of the particle. As t tends to infinity, x ka value will tend to um by k, meaning there is a certain line this particle will never cross. If you take this point as x is equal to 0, this point as x is equal to mu by k, this particle will move in such a way, it gets closer and closer to this line, but it will never reach that line. It becomes eventually vertical. You can ask a question like this: what is the maximum x coordinate the particle can reach, or what is the boundary there? This projectile will never cross that vertical line. It will get closer and closer, and eventually at infinity, you will reach a terminal velocity, which is mg by k. Horizontal velocity becomes zero. Is that clear, everyone? There. This is how they can frame questions. Again, not a main level question, but yeah, viscosity and kinematics. All clear with this? Let's go ahead with more. Projectile, let's get this. Two buildings you throw in with speed 20 and theta. Find theta if the stone goes into the window. Equation of trajectory, find range and h max. When we started the class, we have 52. Now we have 46. 6 people left. That is much less actually. I thought more people will run away. People are becoming sincere. Difficult times. Get this stuff. These are proper men's level questions though. So kinematics, if they want to play around, they can introduce viscosity Stokes law, F is equal to kV bar. How to do this thing? Take the initial point as point of projection. Always, whenever they say it lands there, it lands here, indirectly is giving you the coordinates 20, comma minus 20. Equation of trajectory, y is equal to x tan theta minus g x square by 2 u square cos square theta. Substitute here everything. So this will be 20, this will be 20, this will be tan theta minus 10, 20 square, 2, 20 square, cos square theta will be sec square theta. You'll get 1 plus tan square theta. You get a quadratic in tan. So you actually get two answers. This can be compared with y is equal to x tan theta into 1 minus x by r. This is the second form of writing this thing. So this is 1 minus x by 2. Then you can clearly see range is equal to 2. And where do you get h max? You get h max when half of the range, right? Y will be h max when x is equal to r by 2. Substitute there, you'll get the h max also. Clear with this? Or you could have said dy by dx is 0. At the h max, slope is 0. You could have played that way also. Let's get this. Particle is projected 20 root 2 meters per second, 45 degrees. Find time and speed h max by 2. Time when the angle makes 30 degrees. Find the angular momentum at time t. Find radius of curvature. A centripetal, A tangential at time t. Let's get this. So that's what I'm saying. Don't always see things as one single questions. Try to connect it to as many things as possible. So even though we said we are doing kinematics, literally you can see I'm jumping every other chapter. That is the best part about physics. Try. Get them all. I'll give another 2-3 minutes. But I hope by now you figured out how to do each and everything. At least the rough idea you should get. I'm not saying you should know the end to end. You see the question and I should know, okay, I should use this equation, I should do this, I should do that, and yeah. That recollection is what is more important. The faster you can recollect, the faster you get. And that's what we're trying to do in the speed test. If you see in a speed test, if you actually think and try to solve the question, you'll be gone. You see the question and instinctively you should know what to do. Actually, you're thinking, but it's happening so fast, it feels like, you just know it. And you will reach that state when you do a lot of questions, right? You will be in zone. Cricket mein they say na, you're in form, matlab you're just hitting everywhere, right, left. You're in form. You'll reach that state if you put a lot of work every day. You're putting 10, 12 hours ka work. You're solving, hundreds of questions every day. You'll reach that state in a month or so. You'll be a little exhausted, but you'll reach it. Find time and speed for h max by 2. That's a good one. Huh? It looks like easy, but it is actually a little tougher one. So h max by 2, you can first find the h max. That I will leave it to you. That will be u square sine square theta by 2g. So you know h max. Now, since you're only talking about the vertical coordinate, use the vertical equation. Sy is equal to uyt plus half ay t square. This will be h by 2. U by 2 will be u sine theta t. This will be minus half gt squared. So it's not tough, but yeah, this is how you do. You get a quadratic, you have to put some time there. You'll get the thing there. You want speed, then we use vy square minus uy square is equal to 2ay sy. You write your kinematic sequence in the vertical direction. This will be vy square. This guy will be u square sine square theta minus 2g h by 2. You want the time when it makes an angle with the 30 degrees. I hope you remember that formula. Tan alpha is equal to u sine theta minus gt by u cos theta. This is simply vy by vx. But he said 30, he didn't tell you which 30. So take 30 plus or minus 30. While going up, while coming down, there will be two answers. And how to find the angular momentum? There are two ways to do the angular momentum thing. You can do L bar is equal to mr bar cross v bar. I already told you how to do r cross v bar, but there's a better way. We also know torque is dl by dt. So change in angular momentum will be integral torque dt. So when this particle is flying, the only force acting is mg. And this distance will be u cos theta t. Therefore, torque will be mg u cos theta t direction minus k cap. So your change in angular momentum will be integral. That will be mg u cos theta t square by 2 minus k cap. Since it is initially passing through the thing, that will be 0. So this will be your L final. Clear with this? That would actually save you a lot of time. But again, exam it should click. If it doesn't click, just do r cross v bar. And how to do the radius of curvature? So when the particle is flying in air, hope you guys remember how to do radius of curvature. Don't mess the velocity. Keep the velocity as it is. Resolve the acceleration. So the acceleration is g. Resolve this into two components. This angle is alpha. This is alpha. So this will be g cos alpha. So the component perpendicular to velocity is a centripetal. This is g sin alpha. The component parallel to velocity is your a tangential. There. And what is radius of curvature? V square by a centripetal, which is v square by g cos alpha. And we also know in a horizontal thing, u cos theta is equal to v cos alpha. So if you substitute here, you end up with u square cos square theta by g cos cube alpha. This is also a question in the exam mains. Mein. R is proportional to 1 by cos power what? It's cos cube alpha. And you want to find alpha as function of time t, that also we saw. U sin theta minus gt by u cos theta. Clear with this? At the highest point, radius of curvature will be minimum. So this is your A perpendicular component. So whenever you want to find the radius of curvature, in case you forgot, don't do anything. Keep the velocity as it is. And let's say the acceleration is this way. You don't resolve velocity. You resolve acceleration into components, A perpendicular and A tangential. This guy will be A centripetal and this guy will be A tangential. And we know A centripetal is nothing but V square by R. So from here you get the radius of curvature. Circular motion though, but yeah, that's how we do that. Right? More about the circular motion, radius of curvature, we did a very detailed discussion in circular motion. You should check it out in case you don't remember. Clear with this? There, so I can ask you kinematics or angular momentum or radius of curvature. Let's get this. Two particles are projected, u1, u2, theta 1, theta 2. Find the condition for collision or minimum distance. Find the angular velocity of B with respect to A. What is the trajectory of A as seen by B? C is an easy question. Let's finish off. Last one for the day. That should have given you a little energy. Let's get this. There you can see that every session we are doing roughly, I think, even the numbers, each number I'm showing one, I'm putting 4 or 5 questions in each. So I think we are doing roughly at least 30, 35 questions maybe. But you can see, right, we are covering a lot of variety. So that's what I'm saying. When you attend the sessions, think of like you're sitting and studying with me for 2 hours. So don't think it's a waste of time. Get them. Find the condition for the two particles to collide, or find the condition or find the minimum distance between them. Obviously, minimum distance when it becomes 0, that is your condition for collision. I hope you remember the actual thing. This is not the actual one. The actual one is both are on a building. Yeah, that is even more messed up. You should definitely check out the notes for that. There you have total 7 variables: h1, h2, u1, u2, theta 1, theta 2, d. So what are the condition for collision? Let me do that more generalized one. Let's say we have two buildings, h1, h2. Let the distance between them be d. So when you're projecting them, the velocities will be u1 sine theta 1, u1 cos theta 1, u2 cos theta 2, and u2 sine theta 2. So this is for A and this is for B. So stop any one of them. Let me stop B. So if you solve the problem, stop A with respect to A. So A will think, okay, I am at rest, relative motion. And now B will think B ka velocity has become vertical direction mein u2 sine theta 2 minus u1 sine theta 1, u2 cos theta 2 plus u1 cos theta 1. So this is what, and A relative is 0 because both have same acceleration. So the path of one projectile with respect to another projectile is a straight line. So now this guy will go something like this. So this is the path of B as seen by A. Now, simple thing. If you want to collide, then what should happen? This path should pass through A, isn't it? But if you want minimum distance, then this would be the minimum distance. The line joining from a point to this thing. It just becomes a geometry there. This distance is D. This distance is H1 minus H2. Let this angle be alpha. Let this angle be theta. Tan theta will be simply the vertical component. Let's not take theta. Theta already I'm using here. Let's call it beta. Tan beta is simply u2 sine theta 2. u1 sine theta 1 by u2 cos theta 2, u1 cos theta 1. That means this balance angle will be beta minus alpha. This is the minimum distance, so let's call it C. So AC will be AB sine beta minus alpha. That's your minimum distance. Clear with this? And what is AB? AB you can find root over h1 square minus h2 square plus d square, and you got everything. Numbers are given, you got to solve this. Clear with this? What is the condition for collision? Alpha and beta will be equal. Tan alpha will be h1 minus h2 by d. That is a condition for collision. What else did I ask you? Omega. So same story here. If you stop A, do you think B is going with u2 sine theta 2 plus u1 sine theta 1? u2 cos theta, this is minus. So basically this component will be your V tangential. This velocity is responsible for rotation. So omega will be the V tangential by distance between them. Making sense? If you stop A will think B is going perpendicularly with this velocity and it is coming towards me with this velocity. Which velocity is responsible for rotation? The sine theta components. So the angular velocity will be u2 sine theta 2. So that is how you find omega. Find the relative velocity perpendicular to the line joining them and divide by the distance between them. Clear with this? There you can actually play a lot in projectile. Okay, with that we'll wrap up for the day. We'll catch up on Monday. We'll continue with more. We will see a little more problems on the Rainman problems, Riverman problems. Those things also we have to do. And then we'll go ahead with NLM friction and all that stuff. Okay, with that we'll wrap up for the day. So tomorrow we have a meeting at 9 o'clock, right? So just a general discussion on how to go about it and all. So that is one. And Monday we will catch up. We'll continue from here at 6 o'clock. So any doubts, anything else, please stay back or else you're free to leave. So I'll see you on Monday at 6 o'clock. Take care, stay safe.
You're on